Okay, it's had a balanced charge and it's nicely charged. All cells really close to 4.2, ready to go. Okay, this is an attempt to check out the capacity of a WindForce 5200 milliamp 20C 6S LiPo. Anyway, you see it's whacked straight up to 50 amps, but it's rapidly dropping down. At under 10 seconds it's already gone down to 40 amps, and it's dropping 40 amps and the volts. It's down at 16.9 already, and it's coming down, and within 30 seconds it's down to 30 amps. Now, my understanding, from what I can gather, is that with a LiPo, the voltage under load should be an absolute minimum of 2.5 volts per cell. So with a 6S battery, that gives 15 volts, and you can see it's dangerously close to that at 15.2 after just 50 seconds. So my understanding is at 15 volts you're starting to get cell damage, and irretrievable cell damage. So I'm very worried at this stage, but the battery should be way within its capacity. Anyway, as you can see, it's settled down at 30 amps, and we've had, now this is rated at 20C, so it should be able to discharge at 100 amps, but I'm just aiming to try and get somewhere near 50. Feel free to fast forward at this stage. I just left it all in so you can see that it hasn't been cut and spliced together. So you can see the hand whizzing round. You can see the full capacity of exactly what we've got here. Okay, at this stage I disconnected it for I think 30 seconds, or maybe in a minute. You have to watch and see for yourself, because the current drain was getting low, and I really wanted to try and keep it up. So it's basically just on some coils of wire. So I just took out a loop at this stage. You can see it's dropped right off now. So all I'm doing at this moment is disconnecting one of those loops to reduce the load, so to bump the amps up once again. So that's all that's happening here. So you can see it's just a break in the proceedings while I try and get it. I didn't have a motor or anything I could run it off, but I wanted to try and reproduce. I wanted to think of a minimum of sort of 50 amps was what I was aiming for. I wasn't able to do that, but I think once this gets connected back up again, it comes up a little bit more, about 30 again. Okay, it gets reconnected at the top of the hour, and as you can see it whacks up and it's over 50, but I don't know what it is, but it's only for 5 seconds, 6 seconds. It's already coming down, and it settles down around about 35 and carries on 35 amps. Now the battery did get extremely hot during this process, and perhaps understandable, but it also grew and it got quite swollen. I haven't got measurements of it, but it did swell up alarmingly, but it shrunk back when it cooled down. As you can see towards the end of the clip, the voltage started to drop off dramatically under 15 volts, which is under 2.5 volts per cell, so I had to cut it off. And by my calculations, and certainly it wouldn't claim to be anything like laboratory standard, I figure this is giving about 2,900 milliamp as a rough capacity, which is woefully inadequate. And plus, I did try it again at a slightly lower discharge, and it fared better. but who's going to buy a 6S battery and run it at sort of 25 amps anyway? You know, this is something I wanted for a ducted fan models, and I was looking at 65 amps, so I just don't think it's going to do it at all. I don't have the equipment to test it, see what it would do if I tried to discharge it at 65 amps, but I have a horrible feeling it might not make it. In any event, it's certainly nowhere near the capacity that it says on the tin, so to speak. Now, if you watch now, you can see the voltage dropping off rapidly, way, 13.9, 13.7. That theoretically is cell damage, but it did come back up again once the load was off, and it's charged back up again. But still, you couldn't risk running it any longer than that.